What's up everyone? Welcome to another episode from Pacific Arc Tig Welding. My name's Dusty. And welcome to today's episode, how to clean your aluminum for welding. For all you arc heads out there who watch my show every week, thank you very much, welcome back. For everyone that's new, welcome to the show. Be sure to jump back and check out the previous episodes. On my channel, I do everything to do with TIG welding. I do TIG welded art pieces. We do TIG welding gear reviews. We do TIG welding demos on different techniques and stuff like that. So if you're new to the channel, jump back, check out all the stuff that I've done already on here. There's a couple different playlists you can check out. If you enjoy those videos, please be sure to subscribe, like, and share. I always feel bad asking, but it really helps my channel grow, and I'm trying to grow it as large as possible because obviously the more people that watch these videos, the more videos I will make. As well, be sure to follow along on Instagram. My Instagram handle is right there, as well as my website. You can check the link to my website in the description for this video. I have a blog on there I've just started, so be sure to pop on there and check it out. I got information about my online training program where I train people online how to TIG weld. So yeah, pop on over, check it out, follow me on Instagram, I appreciate it. So today, we're gonna go over how to clean and prep your aluminum for welding. This is something that's popped up in my comments a little bit lately. I really appreciate everybody weighing in. I actually put a call out a few episodes ago to ask how people prep their aluminum for welding. Quite a few people popped on there and let me know how they do it. Across the board, everyone seems like they're doing a pretty good job, but I just figured for the sake of it, we go over everything today and I'll show you how I prep my aluminum for TIG welding. So first off, why is this important? Seems like a pretty simple question, but it's very, very important. Reason being is a lot of the most common weld flaws that you will encounter when learning how to TIG weld, a lot of them can be attributed to contamination or lack of preparation when you're getting ready to weld something. So check this out. I'm gonna show you on screen right now. This is probably the most common one that you will see due to contamination problems. This is called porosity. Welding porosity is basically an inclusion of something in your weld that has formed little bubbles. What happens is it can either be attributed to moisture, any kind of unclean welding environment definitely can develop porosity. Problems with gas and things like that can also cause porosity. Porosity can be caused by several different things, but one of the most common things that I encounter is contamination. Contamination from stuff just around the shop that's made your metal dirty, or if it's contamination from grease or oxides and things like that that are left on the material that are not properly taken care of. Porosity is a problem because obviously it can lead to weld failure, whether it's weld failure in a weld test setting. So if you're doing a test at a school or something like that, or being tested on the job site, porosity will almost always cause you to fail right away. If there's a little bit of porosity, different guidelines will allow you a little bit of porosity here and there. Again, I'm not going to speak to code because code is different everywhere, but from what I've encountered, a little bit is allowed where I live in Canada. It changes, it's very subjective to what the testing parameters are and how it's being tested. So I'm not going to speak to logistics on that, but I will tell you that porosity is a very common one that forms due to contamination, and it can almost always cause you to fail. So either fail a weld test, like I said, in a school setting or being tested on a job site, or your welds going out, you thinking that they're cool, and then they might break on a project or something like that, or fracture or cause other problems down the road. So porosity is one that's very common, and what we're gonna do here is probably gonna give you a good start in eliminating this as a problem. So in here today, I'm actually getting set up to do a couple other welding videos. So I got some plate here, which I'm gonna be using in another video. But what I've gotta do is I gotta make sure it's clean. Basically, I cut this up with a bandsaw. This is some plate I've had kicking around in my shop here. My friend got it for me. I kind of know where it came from. However, I don't totally know what it's been exposed to, what's on it as far as grease or any kind of contaminants and things like that. So I need to make sure it's clean before I get going with it. The plate I've got here is 1/8 inch aluminum, and it's 5086. I gotta make sure it's clean before I get going. So there's a lot of things that can contaminate a plate. One of the most common things is the way that you cut it. So like I just said, I cut it with a bandsaw, but then what I did, as you can see, I've hit it with a belt sander. So the belt sander is nice because it makes it nice and straight. The edges look pretty good for welding, so welding up joints. This one is gonna actually have a piece of pipe welded on it, so the edges don't matter too much. But what can happen is that in a lot of shops, you don't know what's been on that belt sander that you've used to basically prep your material. So like I said, I'm not gonna be welding the edges of this, I'm just using this as an example. But I don't know what that belt was used for. Someone else could have been buzzing some steel down on it. I definitely know there's a lot of stainless steel going around in our shop. So chances are there's definitely some contaminants on there. So what we want to do is we want to make sure that we eliminate any variables that could be included with the prep that we've done on our plate. So another pretty common way that people cut out plate, plasma cutting. Plasma cutting is one that's very common. With plasma cutting aluminum, what can tend to happen is that you get a inclusion on your kerf. So as you cut through material, it can blow oxide through and it can stick to the cut. So it's always a good kind of rule of thumb if you're running a plasma cutter, even if you do a nice straight cut, which a lot of people do. I've seen some really nice work with plasma cutting, but they'll just dust it down with a good grinder or something like that we're gonna go over here today, and then make sure it's nice and clean after they do something like plasma cutting. Another different way you'll see a lot of aluminum come, I myself get to do a lot of work with aluminum that's been water cut. So water cutting is awesome because it's super precise. You get a little bit better as far as a kerf goes. You get a nice square cut for the most part, unless you get into thicker stuff, then you have to deal with a bit more of a kerf. But what tends to happen is that a lot of water cutting places will have, like I said, been working with other types of material. So some of the water cutting places that we get our stuff from also cut stuff like mild steel, they cut stainless steel, they also cut some other stuff. They'll cut plastic for us. You don't know what your water cutting kind of circumstances were for when they're cutting, so chances are, as you will see with most water cutting stuff, there's a grain left on the side. And 90% of the time, your grain is gonna have some kind of contaminant with it. So even if you have the stuff, it's got the plastic sheeting on it or anything like that, it's really clean, even shearing and stuff like that. Again, shearing, a lot of people shear stuff with the plastic on top of their material. So now that plastic has been ingrained into the cut. So it's a good rule of thumb that anything that comes cut to you, or anything that you've cut basically, you should probably clean it before you start welding it. A lot of stuff that we get from machining, so our really nice machine parts out of 6061 or whatever we end up getting stuff machined from, T6 aluminum. You know as well as I do, a lot of the machining places use cutting fluid and cutting oils and machining oils and tapping oils and all kinds of stuff like that. This stuff can be everywhere in those machining shops. Even the most clean, spick and span machining shops will have some kind of contaminant that's usually left over. It's not a big deal. We're gonna go over some stuff here today that's gonna help you to get that stuff super clean. Another last way, basically you can have contaminant on your plate or machine parts or anything like that you're getting ready to weld, is just general handling. As you probably know, if you work in a welding shop, most people have dirty hands. Even dirty hands, dirty fingerprints, greasy fingerprints can be on your metal. This will contaminate your metal, so it's always a good idea to basically assume that everything that comes to you on your welding table needs to be cleaned, and it's pretty simple to clean. It's just a matter of taking the time to do it. So like I said, fingerprints, oil, stuff like that is really common around your shop, even grinding dust in the air like that. Somebody over the flash screen from you may be grinding some stainless steel or something like that. Hopefully not, that's kind of rude to do next to someone. All that stuff can literally fall and settle on your plates. Where I work, I usually have material just kind of sitting around. It may sit there for a week or two before I end up getting to it. So that's time that stuff can be getting covered with something that can contaminate it. So again, like I said, by the time I actually get down to welding something, I'm gonna make sure it's completely contaminant free and ready to go for welding and getting the best conditions for the best weld possible. So there's also different types that your oxide can get messed up with aluminum. So one of the most common ways that I see generally, we live next to the ocean, so we have to deal with this quite a bit. It's called water staining. I've also heard people call it hydrated oxide. That's a cool name, sounds pretty fancy, but yeah, basically what it is it's a collection of moisture, whether it be from the atmosphere that just gets something damp and then you stack plates together and they sit stacked like that for a little while, they can form this oxide. So I'll show you a clip right now. This clip, you see a pretty severely piece of aluminum that's been water stained. Yeah, this one, I don't know what happened to it. It might have been sitting outside or something like that. Or like I said, from water cutting, sometimes they come back damp, they get stacked in between different other types of plate and it can get really messed up. As you can see here, it's gonna be a real problem. You're not going to be able to weld this. I'd say that with water staining, virtually the only way to take care of it is to aggressively remove the material. So we're gonna go over that in a little bit here, but that's an example of a pretty severe oxide that's formed on the surface of your aluminum that you 100% will have to deal with. You can set your machine up where you can tend to punch through a lot of oxides and stuff like that pretty efficiently. However, I found with water staining is something that you can't really punch through. It basically has to be removed. You need to remove that oxide layer and then get the aluminum underneath nice and clean again, and then you can weld on that. So let's start off with something real simple. So we're gonna talk about the first type of contaminant that I talked about as far as like grease and oil or stuff that's been left from a cutting process. So as you can see here, I've got probably 3 of the most common things that I found and that I have used to clean aluminum. We got acetone here. Acetone's a very common one. Lacquer thinner. Lacquer thinner is another very common one. I've probably used lacquer thinner the most out of all of these. The other one that I heard mentioned a lot was isopropyl, rubbing alcohol basically. All 3 have their different advantages and drawbacks. I spent a lot of time going through welding forums and stuff to get ready for this episode. It was so boring. Reading all this stuff was incredibly boring. So I'm basically just gonna rattle off a couple quick things I learned, as well as the stuff, obviously, because I've worked with this a lot, that I found works best for what I do. So probably one of the most common things I saw on the discussion forums was, which one's better? Acetone, lacquer thinner. These 2 tend to be probably the most common out of most things that you'll see out there, acetone and lacquer thinner. It was really tough to figure out what the proper answer is for this. Obviously, if anybody else out there has looked on welding forums, it's a bit of a zoo. Everybody has an opinion, which is totally fine. And again, what I'm gonna say here is just my preference. I'm not saying it's the right way. I'm not saying other ways are the wrong way. It's just my preference. So what I basically saw the most of, acetone seems to be the way to go. A lot of people prefer acetone because I tend to actually, when I'm using lacquer thinner, what tends to happen with lacquer thinner is that in some conditions, it may be when it's a little colder, weather changes and stuff like that, you can wipe down your material with lacquer thinner. But what tends to happen is that as it evaporates, different types of greases, different types of contaminants, even though you've wiped it around and it's evaporated, it's left a tiny little bit of a film on the surface of your material. So even though we've cleaned it really well, we've eliminated probably 99% of contaminants on the surface or on a weld joint itself, you will tend to have a little bit of a film left over. And I know that this can be annoying. I've actually had some porosity pop up in a few weld tests, and then when we switched to acetone, magically the porosity went away. So obviously that's kind of anecdotal, but that's what happened. So we've tended to switch to acetone for prepping plates for weld tests. For the most part, it's better. I don't know if that's actually the fix or not, but definitely between the 2, you're gonna eliminate most contaminants. Lacquer thinner, I still use most of the time, even if it's just to, if I've done a bunch of layout and then there's pen all over the piece that I've laid out and I'm getting ready to weld it, I don't want to cook the pen into the material, I'll use lacquer thinner. It's real easy. It's cheaper too, so I mean, not by much, but yeah, you can use it real easily to clean most stuff that you need to off of the surface of your aluminum. Acetone's about the same. It tends to clean probably just as well. I do tend to find that when it evaporates, like I said, I don't see much of a film left over. So when dealing with like thicker grease, heavier grease, I will find I tend to see a little bit of that film with lacquer thinner. I tend to see less of it with acetone, but again, it may change for, obviously there's different types of crazy grease out there and stuff like that, so it's not gonna work for everything. Acetone doesn't seem to be a magic pill. It might be, again, I don't know, but from my experience, either of these 2 do a pretty good job, but if I had to choose between the 2, I'd probably pick acetone. So the other one I saw a lot of talk about was isopropyl rubbing alcohol. I have used this in my shop here for little things here and there. If I'm working with a clean piece of stainless steel or a clean piece of aluminum, this stuff I probably is gonna do just as fine of a job. However, because I got this stuff kicking around here, I use this stuff because it's just a little bit heavier dutier. Anyway, his stuff works a little better than this. One thing I did read on the forums was a lot of people tended to find that isopropyl or rubbing alcohol did not cut through grease very well. So if you have a heavier grease or something on the surface of your aluminum, you can wipe it down all you want, and this stuff tends to just smear it around. It might get rid of some as it evaporates and burns off. Yeah. For the most part, it didn't seem like it did a real good job of heavier grease. So if I were dealing with something that had like a machinist oil or tapping oil or cutting fluid or something like that, I would tend to use this stuff here. So again, I'll throw this out here as a liability or whatever you want to call it. If you were going to use some of this stuff, each shop should have its own MSDS sheets. MSDS stands for Material Data Safety Sheets. So MSDS, obviously everything that you buy will have MSDS information on it. It's on here somewhere. I don't know. But yeah, make sure you do your research on MSDS. You can look online. There's stuff you can easily find online to find out information on MSDS. So I definitely recommend if you're going to be keeping this stuff around, you want to make sure you know how to deal with any fires. This stuff is flammable. You need to make sure you know how to deal with chemical fires or anything else that may be combustible in your shop. So I'll definitely throw that out there. When you're working with chemicals like these here, I definitely tend to keep them away from where I'm welding. They are extremely flammable. So if there's any kind of flash point with these guys, you need to read up on it. Make sure you're safe and make sure you don't blow yourself up. So before we move on from the chemical side of things here, let's give a little demo. I just want to show you kind of how dirty your stuff can be, even though this stuff actually has been kept inside. Hasn't been exposed to weather really much like that. So let's give it a quick wipe down and see what's on it. So first off, obviously, because this stuff is kind of gnarly, you want to wear gloves. You want to wear eye protection. I was working with a dude one time and he popped the lid off, and the stuff was like, I don't know if it was because it was really warm out or something like that, but the pressure that was in the container expanded as soon as he opened it, and it flipped up right in his eyes. We had to go to the hospital for that one. That one was kind of crazy. So make sure you protect yourself, protect your neck, protect whatever. Now obviously, when you're getting ready to use whatever this is on some material that you're gonna be doing, you wanna use a clean rag. Like we keep many rags around here. I keep a lot of rags around my shop. As soon as I use them for one thing, I usually throw them out. Because what you don't wanna do is get a bunch of oxide off of some aluminum or something like that, and then I go to do one of my really nice, or at least I think it's really nice, stainless TIG welding art pieces. I don't wanna use that same rag because it's got some crap on it that was on the aluminum oxide. Now I'm gonna be wiping it all over my nice art piece that I'm gonna be doing. So I definitely recommend swapping out your rags. Keep a lot of them around your shop, keep them clean. Some people wash them in washing machines. You can do that. I don't think my wife would be too stoked if I did that, but whatever. So let's just do some acetone here. This stuff smells super powerful. So that's why a well-ventilated area is always good. Here we go. So check that out. This stuff's been stored indoors. It's nice and dry in here. It's got a little heater in here, so no extreme temperature fluctuations, but as you can see, it's dirty. There's freaking dirt all over it. So that's just like there's been a bit of sanding on that plate, but that plate is almost brand new. So there you go. There's a good example of why we just want to clean our aluminum. So what you want to do is you also want to make sure if you have something that's been sanded like this, it's getting ready for weld prep. You want to aggressively make sure that you clean out the welded edge as well. So there we go. There's more dirt on there. That was sanded like 2 days ago. So that'll show you that there is contaminant creeping in there. But something as quick as that, like that took me what, 30 seconds, and now it's basically, you got a much better chance of eliminating problems with your weld as far as porosity and things like that by just doing something simple as wiping it down with acetone. So now that we've been over the kind of chemical side cleaning of things, let's move on to the more mechanical type of cleaning, as some people like to call it. So one of the most common things you will see a lot of welders use is a wire brush. So not a lot of science behind a wire brush. It's basically just some type of handle with a good stainless steel. It's got to be stainless steel wire brush because obviously mild steel will form oxide on it as well. The stainless steel wire brushes will not form the oxide really. They will pick up oxide, however, like we'll talk about in a sec here. But this stuff's going to be better for you as far as like making sure that your wire brushes will stay clean in storage, which is really good. So yeah, these guys are the way to go as far as like probably the most common mechanical type of way to clean your material for welding. So wire brushing technique. This is something that I kind of went down a bit of a rabbit hole with. So somebody on a previous episode hit me up. They saw me doing a weld joint. The weld joint was a corner to corner, I think, something like so. And what I was doing was I was wire brushing like so. Now, what I was doing was I was explaining that when you're wire brushing something, you want to make sure that you want to wire brush lengthwise to your weld path. So reason that I say you want to go lengthwise to your weld pass or lengthwise to the direction that you are going to be welding is because if you're going across or whatever you want to call it like that, if you're going this way over a weld joint, a lot of the time you're going to be scraping oxides or contaminants out of a weld grain, and it's going to just be going down into the weld joint. When you wire brush lengthwise like so, it's going to eject a lot of the contaminant and material out of the weld joint. So that's definitely the way that you want to go. However, somebody hit me up, and I'm sorry, I can't remember who it was, but if you're watching right now, thank you very much for hitting me up. There definitely is a school of thought that you should be wire brushing in one direction only. I looked into this, and it's totally right. So there you go. I learned something one of my episodes, and somebody hit me up in the comments below and told me how they do something and reason behind it, and I looked into it, and it actually seemed like definitely the smarter way to do it. So what I saw is that it was kind of weird, actually. I saw a video on someone doing it and talking about it, and then in the next clip they were wire brushing both ways. So take that however you want, but definitely it did make sense, because what can happen is that when you wire brush one way, like I said, you're pushing any oxide or any contaminant in a certain direction, and when you double back and grain it back in, it can become impermeated into the aluminum surface that you're doing here. So a lot of the time with even softer aluminums and stuff like that, these things are hella sharp. They will tend to grind stuff back into the material as well. It makes a lot of sense that you wire brush in one direction. Definitely, if you want to get like super crazy about making sure your stuff is super clean, that would be the way I want to go. Yeah, so take that however you want. There are a lot of people that say you should go one way only, but you see a ton of people going both ways. But regardless, lengthwise to your weld joint, that's going to be probably the best way to do it. As well as what I've done here, so I have a bunch of stainless steel wire brushes. If I'm going to scuff up some aluminum like so, and then next project I do to do some stainless TIG welding, I'm going to get a different wire brush. This is very important because, like I said about belt sanding and stuff like that, if you are going to be using something to clean your material, you want to make sure that that thing you use to clean your material is going to clean your material, not leave some other crap from another type of material on your new material. So it's really important. I have a couple different jars, mason jars. I keep all my aluminum ones that I've used and are still okay in one jar. I keep my stainless steel stuff in another one. So it's just best to make sure you do not cross-contaminate anything. These things are not very expensive, so don't ever feel bad about when you're done. Throw them in the garbage, grab a new one, and that way you know the next thing that you prep up with a wire brush is going to be super clean. So the next thing that probably I use the most is these things here, Scotch-Brite pads. So these things are pretty awesome. So it's by the company Scotch-Brite, 3M. They make a couple different grades. This is as you can see here, the very fine stuff. It's very fine. This stuff is nice. Basically, what you can use this stuff for is kind of the same as what you can use a rag for. A lot of the time I will get like an acetone or a lacquer huffer, and I will put acetone or lacquer on this, and then I can actually treat a surface. So you will tend to treat a surface a little more aggressively than a rag with this. So when you're using chemical and stuff like that, this is great for using that. It will not dig into the material and remove as much oxide on a surface as a wire brush. Your wire brush is probably the best one as far as like a hand mechanic type thing to get oxide off a surface of a material. However, these guys work really good as well. One thing I do find that they work best for is that, like I said, if you get some lacquer or something on it, prepping an edge for welding. It's probably best prepped by using something like this here. A wire brush will tend to kind of skip off, might be a little tricky or something like that. This stuff here works really good to get any kind of contaminant off the edge of something, and it leaves it super smooth. So if you're doing any weld tests or anything like that, where you got joints that go together like a T-fillet, I'll always do that to the end of my plate, make sure there's no crap left in the water cutting grain or whatever you use to cut it. These guys work great. It's definitely something that I would use probably as a little more of a surface or edge type prep. You're not going to get into the material as much as you would with a wire brush, but it works really good. So a little earlier on, we talked about aggressively water stained material. I'll show the clip again. So like I said, this stuff is super oxidized by basically moisture that's been left on the plate. Whether the plate sat outside, I don't know. Whether the plate got stacked in between some other wet material and it sat there on the shelf for a little while, don't know. Regardless though, that oxide is super thick. You have to remove it with something heavier than a wire brush. A wire brush will not really get rid of that. So grinding wheels. Grinding and sanding wheels is probably your only option to get rid of water staining like this. Again, if you're watching, this is just the best stuff that I know of using. Do you know of a better way to get it off? Please hit me up, let me know. I definitely find that wiping it with a solvent on the surface doesn't really take care of it. I've basically found that removing that surface of oxide with a grinding pad or something like that is the best way to do it. So I've got a couple different grinding options here. This first one here is just basically a flap disc or a flapper wheel, some people call it. You can get different grades. This one is a little more aggressive. This grit on here is just monstrous. So this thing spinning at high RPM on a grinder is going to definitely remove material very, very quickly. So make sure that you don't do it too aggressively, that you dish your material by digging it in too much with your grinding wheel. But this guy is probably your most badass option as far as removing oxide. It will happen very, very quick. So like I said, be sure that you are aware of how much material this is going to remove. Your next option, which is probably my favorite, these are basically a heavier version of the 3M Scotch-Brite pads. These are the Scotch-Brite wheels. This is about, I think this is a medium grade one, so not super, super hard. They tend to wear out decently quick. They're pretty cheap too, so you can just get a backing wheel. So they fasten onto a backing wheel for your angle grinder. Yeah, they clean stuff really, really nice. They don't leave much of a like swirling effect. They will leave some, however, it's not going to be anything near as the grinding swirls you have to deal with this guy here. So yeah, these guys are good. They're probably my favorite. They're really indisposable. Like I said, you can just buy a box of them and swap them out as they get dirty. But yeah, those are probably the two most effective ways to remove like legitimate surface oxide, like a water stain. Again, safety with these guys, we want to talk about eye protection. I do wear breathing protection when I'm doing a lot of like heavy grinding, especially I tend to find this pad here tends to make more of a grit that flies off. Something a little finer like this tends to make more of like particles in the air, so particulate, and I do like to wear a mask because I don't like breathing that stuff in. So one more thing I wanted to mention here. We've talked quite a bit about cleaning our aluminum, getting our plate ready for welding. Let's talk about one more thing that's probably really important. That's cleaning your filler rod. Cleaning your filler rod is something that I've kind of gotten into the habit of doing a little bit more lately, because even though they've been sitting here in this nice dry little shop here in my house, they still tend to collect dirt and some kind of contaminant. So even though you probably think that it's cool and everything is clean, not a bad idea just to give it a quick wipe. So put our little safety gear back on here, and I'm actually gonna use a little bit of toilet paper here because we'll tend to see any dirt or anything like that a little bit better. So, Jesus, look at that. You just saw me take this TIG rod out of the brand new box. So look at this. That's just one wipe down the length of that TIG rod. So even though, like I said, this shop is nice and clean, it's pretty warm, it doesn't get any moisture or dampness or anything like that. Clean your filler rods. Your filler rods will thank you. You'll get nicer welds, which is what we're after on this show. I love breaking down things and helping people get the best welding they can out of what they're doing. So again, this is just the stuff I do to prep my material. Like I said, I'm not saying this is the right way. I'm not saying other people's way is the wrong way. Please, if you have other ideas or other recommendations of what I can try to get better results here, leave them in the comments below. I actually really like learning new stuff. I've been doing this a long time. I've been welding for 18 years and I'm still learning stuff all the time. Especially, I've just started this channel 8 months or so ago, and people still hit me up and we talk about things online, and I really appreciate it because I've learned a ton from people just leaving comments and stuff like that. So if you try this out, you find out it works really well, let me know in the comments, hit me up on Instagram. If you know of any other things that work better, hit me up as well. I like learning, like I said. And again, follow me on Instagram. My Instagram handle's on the screen right there, as well as my website. You can go on my website, check out my blog. You can also check out information on my online training program where I help people learn how to TIG weld. But again, thank you so much for watching. I really appreciate it. I hope everyone out there is doing good. Do something nice for someone today. And yeah, for anybody that's watching, thank you very much. I hope you have a good one. Peace.